All right, just a little bit more on working with addition and subtraction. So we've played around with a few different models. We now have an algorithm, but another way addition and subtraction and multiplication and division of integers are patterns. So I just want to show a few integer patterns. And this will lead us into multiplication and division. So for example, I could start with a pattern like 4 plus 4, we love our doubles when we're doing math, is 8, and then 4 plus 3 is equal to 7, and 4 plus 2 is equal to 6. And so these are all pretty straightforward. And then it's going to get more interesting. 4 plus 0 is equal to 4. Now, once we have this pattern and we get the kids at the idea of what it means to be a negative number, there's a pattern going on in this column right here where I'm going 4, 3, 2, 1, 0. What number should come next in this column?
-1.
Yeah, it should be a -1. So the next thing I would write is 4 plus, and we usually write parentheses -1 because the plus and minus next to each other is a little bit weird. And we also have a pattern heading down this column here. 8, 7, 6, 5, 4. The answer should be 3. So we can kind of play around with patterns and say, oh, look, that's a lot like subtraction. And then just put a few more in there for fun. There you go. 4 plus -2 would be the next one. And the answer should be 2 from this pattern. And we can talk about why that makes sense with the kids. 4 plus -3. This should be equal to 1. And 4 plus -4 is equal to 0. And there's lots of ways to think about that. A gain of 4 followed by a loss of 4 puts us right back where we started, the 0 movement. So that's kind of fun. Other things we can do is kind of reverse those patterns. So we play around with patterns like that for a while, and then we might try something like this. Well, we know -4 plus 4 is 0. What about -4 plus 3? And we've played around with the chips, and kids will say, yeah, that's -1. And then -4 plus 2 is going to be -2. And -4 plus, oops, something went wrong there. Did I do wrong? Oh, that's right. That's right. Okay. -4 plus 3. No. Oh, 4, 3, 2. I know. I wanted to do a 1 next. Sorry. Brain fart. 1 is going to be -3. -4 plus 0 should be -4. So we have our pattern 4, 3, 2, 1, 0. 1, -1, -2, -3, -4, -5 should be next. 4 plus -1, -5. So we can generate patterns playing around with signs. We can do this with addition. We can do this with subtraction. So we'll play around with that next, and then multiplication and division. So we can use patterns to kind of generate, if two numbers have opposite sign, a subtraction is happening to lead to that 1. Opposite sign, we have a subtraction happening to lead to that -3. So in lots of different ways, we're trying to build up that intuition about what kind of answer we're going to get, and whether it was a straight addition or kind of an addition subtraction thing. Okay? So integers do lead to some weird new stuff, and the more intuition we can build up about it by looking at it in different ways, whether it's toys or patterns, are super helpful. So you'll find that if you happen to be in a grade that teaches signed numbers, you'll look at it with pluses and minuses, you'll look at it with chips, you'll look at it on a number line, you look at pattern lists like this that kids build on worksheets. Let's do a couple more patterns. So 4 plus, let's do minus now. 4 minus 4 we know is 0. 4 minus 3 we know is 1. 4 minus 2 is 2. 4 minus 1 is 1. 4 minus 0 is, oh, what went wrong there? Sorry about that. 3, where did I get that 1 from? And then again, we have 4, 3, 2, 1, 0. The next number in that list should be -1. So we're going to have a 4 minus -1. And so here's where some kids are going to get confused because they want to think of it as 4 minus 1 because that's where they're used to. But the pattern on this side, 0, 1, 2, 3, 4, should grow to 5, just like these numbers here are growing sequentially. And then 4 minus a -2 is going to lead us to 6, and so on. So based on facts they're familiar with, we can build new facts with patterns. It's kind of fun. Questions on those patterns? All right, so let's start looking at multiplication next. All right, so multiplication of integers, we're going to start off with patterns, then we'll take a look at the chip model, which is like the charged particle model, and we can also do this on a number line. So let's play with 3 this time. So 3 times 3, kids are familiar with multiplication. 3 times 2, 3 times 1. 3 times 0. So we've got a couple of patterns here. The pattern in the first column is all 3s. The pattern in the second column is dropping 3, 2, 1, 0. So I think the next obvious number here ought to be -1, and most of the kids would agree on that. And then the question is, what's the pattern going on the other side? 9, 6, 3, 0. How are these numbers changing?
Decreasing by 3.
Yeah, they're decreasing by 3 each time. And then maybe we might want to write that down because some kids might not see that right away. Now, when we get to multiplication, we've already done a lot of addition and subtraction, usually. And so if we have 0 and we take away 3, we should get -3 as the next result. And so 3 times -1 should be -3. And 3 times -2 would be the next number, should drop by 3 again to be a -6. And sometimes it is helpful to have a number line that's, in this case, reasonably long, at least to show us like 9 and -9. And head out the other way. Excuse me. There we go. And so when we're coming up with this pattern here, we started at 9 and then skipped 1, 2, 3 and ended up at 6. And then we skipped 1, 2, 3 and ended up at 3. And so we're setting up a pattern where we just keep skipping 3, but in reverse, right? Subtracting. And so this would be a nice visual for some kids, how we're ending up with these products. So again, patterns can be helpful. So we're kind of getting at the idea, well, you know, if we multiply 2 numbers that are positive, the answer seems to be positive. Now here we multiplied 2 numbers that were opposite in sign, a positive times a negative, the answer was negative. So we want to start pointing those patterns out. Is that always true? So we can play with some other patterns. Let's fill in one more here. 3 times -3 is equal to -9. And then the kids are used to multiplication. It doesn't matter whether you do 3 times 2 or 2 times 3. So that means -3 times 3 should also be -9. And then we can mess around with this. What about -3 times 2? What do we think that should be? And hopefully someone comes up with, oh, it's kind of like this one here. I think it's going to be -6. And negative 3 times 1, well, anything times 1 should be itself, so that should be negative 3. And then we can say, oh, look, that kind of makes a pattern. Negative 9, negative 6, negative 3. Negative 3 times 0. And with the first number, the parentheses are kind of optional. With the second one, you really need them. So these, I really needed those negatives. Well, something times 0 is 0. What pattern do we see coming down this way in the third column?
We are adding 3.
Yeah, well, we're increasing, we're adding 3. So it's kind of the reverse of what I did over here. I'm heading this direction by 3s starting at negative 9. So 3, 2, 1, 0, I should have negative 3 times negative 1 next. Negative 9, negative 6, negative 3, 0. If we look at our number line, the next predictable number should be 3. And so now we're starting to get to the idea of a negative times a negative is a positive. By just playing with the patterns. All right, so let's see how we would do this with the chips or charged particles. So this is kind of like a pattern model for why multiplication works out the way it does with integers. And I'm going to switch to charged particles instead of chips this time. So again, just like with the addition, I have to state a couple of things. First, what is an integer here? And so my integer key is going to be a plus is a positive, and a dash, a minus, a hyphen is a negative. And then if I put two of them together, that's a 0. And then we've got a bunch of different versions of multiplication. We could do repeated addition. We could do groups of. So let's pick, how about groups of? Multiplication means groups of. And so just a reminder of that, 3 and 2 are both integers. So I just want to show what 3 groups of 2 means. So what is 3 groups of 2? Well, one group of 2 looks like that. A second group of 2 looks like that. And a third group of 2 looks like that. So combined, I have now a group of 6. So 3 times 2 is 6. And I could do a similar problem by saying, okay, what are 3 groups of negative 2? And with my model, my key up here, I can say, oh yeah, well, this is a negative 2 right there. There's one group of negative 2. There's another group of negative 2. There's another group of negative 2. And combined, right, we put those together, we have a group of negative 6. So 3 times negative 2 is negative 6. So some problems just work out great based on what we did with addition, but it doesn't always work out that nice. Like, let's try negative 2 times 3 would mean, what is negative 2 groups? Oh, this is getting weird. Negative 2 groups. Oh. of 3. Well, I know what a group of 3 looks like, and I know what 2 groups of 3 looks like, but this negative there is throwing me. Okay, so, weird. What do I do with that? Okay, so I'm viewing this as a negative, but that dash right there, doesn't it actually mean other things sometimes? Like, what else does that mean, that symbol right there? Sometimes doesn't it mean takeaway? What if I tried that? Let's see. Take away 2 groups of 3. Maybe that's kind of weird. Take away from what though? Well, up here, I guess we added 3 groups of 2, didn't we? Added to what? Well, I mean, we started with nothing and then we added 3 groups of 2. Okay, so here in the second one, we added 3 groups of -2, starting with nothing, really. Okay, so so starting with nothing, what's another word for nothing in math?
Zero.
0, yeah. So all of these really started with 0, and then we did stuff. Okay. So that's how we can interpret this right here. So I'm going to go to a new page and give that a shot, see if I can pull it off. Okay. So this is my interpretation of -3 times 2, right? Oh, -2 times 3. Sorry. Negative. It's getting late. I'm forgetting what numbers I'm doing. 2 times 3. I got it this time. So starting with 0. Take away 2 groups of 3. All right, so here's nothing. And there's nothing to take, so I got to find 2 groups of 3 to take away. So to do that, I'm going to have to throw in a bunch of zeros. So there's this 0, and then, oh, I was going to use charged particles, wasn't I? So here's a 0, and here's another 0, and here's another 0. Do I have 2 groups of 3 yet? The answer is no, so I keep going. So let's make another 0, and another 0, and another 0. And I think I have 2 groups of 3. Okay, so I'm starting with 0, and then I'm going to rebuild it. And I still have 0, but now I can take 2 groups of 3. All right, so then I want to take this group, oops, switch color, switch that time, yeah. Take this group of 3 out, take that group of 3 out, so take, and then it looks like I have this left behind, which is -6. So we had to kind of revision a little bit what groups of meant to deal with the idea of integers in case the negative comes first. So if it's a positive, we're starting with 0 and we're adding 2 groups of 3 or 3 groups of 2. If we're started with a negative, we got to take away. Can we make this work for -2 times -3? So give it a shot. Write down, based on the example we just did, which was to take away, starting with 0, take away 2 groups of 3. This one would be starting with 0, take away 2 groups of -3. See if you can draw a sequence of pictures that does that, and then we'll compare notes. So take away is the first negative sign I see. And then the second one just gets treated as a negative. All right, so give that a shot, draw it, I'll draw mine, and then we're about out of time. So hopefully you get a similar result, that leaves positive 6. And again, we could have done the same thing with the chips. I just chose to draw it with charged particles instead. Question. Okay. So we are not quite done with all the topics in section 5.1, but we're getting close. We still have to do division. We have to come up with algorithms for multiplication and division. And then we have some properties to talk about again, like commutative and associative and the zero property. And then some estimation type tricks, which are mostly based on the algorithms. Difference between a model and an algorithm. So everything we're doing here is modeling. So we have the charged particle model, and then back here we were modeling with patterns. When we make rules for how to get the job done, that's an algorithm. So for example, if I want to figure out what is negative 25 times 32, I don't want to draw charges. I don't want to put this in the number line. I just want to come up with a way to determine what the answer is. Okay. So, and we have an algorithm for multiplication. So what is the algorithm? What are the rules? So we don't have to draw pictures, but it's built on the pictures in a sense. So we will continue with that. Next class, we'll also figure out division models and an algorithm and a few other things. So about a half to a third of the next class, we'll finish up section 5.1, and then we will review for the final. The only new thing we've done are all these integers, and then it's based on the previous stuff that we've done. And so I will post some information about a practice final by the next class, some samples of previous finals that I gave. And then the final will be in 2 parts. One part of it you will get on Wednesday, which is the take-home part. And let's see, I'm going to change the due date for the integer homework because we haven't covered everything. But I think you all are knowledgeable enough to finish it on your own anyway, based on the reading. Change the due date to be Wednesday night. And you could always apply a late pass if you want more time. All right, questions before we part ways?